To the walkthrough of my package delivery program. This program is built using Python in the PyCharm IDE from JetBrains. And the goal of this program is based on a scenario of delivering packages with trucks, like mail trucks. The scenario includes 3 trucks and a list of packages. In this case, there are 40 packages in the sample, and they are delivered to different addresses around Salt Lake City, Utah. The packages information is included in a CSV file. It was an Excel file that was converted to CSV with comma delimiters for 8 different attributes for each package, including an ID number, an address, the location, and some special notes for certain packages that may have special requirements. And there's also an Excel file for distances between the different locations, and this CSV is reading in the distances between locations, which correspond to a row and a field of each one of these files. And there's another CSV. This is the address CSV, which mirrors the distance CSV, so that the addresses can be attributed to the distances between the addresses. So that's the basic starting data for the program. And one of the first things that is accomplished is reading the CSV files into the program. This is accomplished in, for example, the distance file here. And this is how that's accomplished. It creates a 2-dimensional list that corresponds to the rows and columns of the CSV file. Something is similarly done for the address CSV and the package CSV. So that's how the information is loaded in the program. It's a 2D list. And the other main part of this program is the way in which the packages are stored. They are also stored, once they've been read into the program, they're stored in another 2-dimensional list in the form of a hash table. And the goal of this was to use an algorithm, or in this case a data structure, which is a hash table, to efficiently store and retrieve the information for the packages. The hash table is a 2D list. It has been established with 10 buckets or 10 lists within the main list of the hash table. And the buckets are assigned with a modulus of 10, which is the capacity for the number of buckets. And so the appropriate bucket is found for a package by looking at the package ID, finding the 1's-digit value, and finding that value, or finding the value of the package ID modulus 10 to get the 1's digit and as the assignment for the bucket 0 through 9 that it's placed in. This is a chaining hash table, which means that collisions are handled. A collision would be when more than one package is assigned to a particular bucket or list within the 2D list. And it's created by the fact that it's a 2D list, right? So when one package is placed in one, another package list can be placed within that same parent list, if you will, for that digit 0 through 9. Okay, so that's the main data structure that is used to store the packages and to retrieve them. There are methods here to insert packages. along with all the attributes for a package. And this also serves as an update. If the package ID already exists, it will update the fields for that package so that there aren't duplicates of a particular package ID. There's a lookup function to retrieve package information, in this case the first index field, which is the address of a package, which is used in the functions of this program. And then there's an update method here to update the delivery status of packages as they're delivered. So that's an overview of how this is organized. There is a primary algorithm which is contained in this truck file. It's called the truck deliver packages. So this executes the delivery program, and it is based on the nearest neighbor algorithm, which is a greedy type algorithm. And what it does is it takes the distance from the origin address, where either the truck is beginning its journey or the current location of the package that was just delivered by the truck. And it looks through all of the addresses of the packages still loaded onto that truck and finds the next closest one to the current address and goes to that one. So this is one way to efficiently reduce the amount of miles and the amount of time that needs to be driven and taken to complete the deliveries of packages. I will briefly walk through how this algorithm works and then execute it. There's a simple console command interface here, and I'll walk through the program in a minute. But just to briefly overview how this works, this main algorithm function works by calling two other functions included in this distance file, which is one function to find the distance between two addresses. And these are based on, as I talked about, the CSV files for the distances and the corresponding addresses. So it looks for referencing that table, the distances between addresses, which is handy to have. And then another function here which loops through distances, calling this distance between function to find the minimum distance. So it looks through each one, and if the next one it looks at, the next iteration is less distance than the previous one, it assigns that as the minimum, continues to do that as it iterates through every one, and eventually ends up with the lowest minimum distance assigned as that value. And these variables are all returned by the function so that they can be accessed by this function, which uses it, and you can see that here. So those distance functions are what's used here. I briefly talked about the looping there, and then in this function, the packages within a truck, which are passed in as arguments, are looped again to find the minimum distance from among the packages loaded in a truck. Okay, one other important point here is that there's a time object, so that if this is part of the user interface, if a user wanted to check the status of the packages at a given time in the day to see how the deliveries are doing, that can be accomplished because this algorithm is checking to see if the time input by the user is before the time that is being taken by the truck to make deliveries, and if so, it exits the algorithm so that the statuses don't continue to update, and the delivery statuses for every package in the program can be provided. Okay, well, that's a lot of description. So now I will actually execute the program through the interface to give a better idea of how it works. So there are 4 options here. The first is to run the entire simulation, number 1. Number 2 is to get a single package status at a given time. And number 3 is to get all the packages statuses at a given time. So let me just start with number 1 and hit enter. I'm going to scroll back up here, and then it shows, it has like a print statement that says the truck number and says which package was delivered first, to which address, and at which time. And it runs through, again, nearest neighbor, going to the next nearest package every time for all the packages in either of the 3 trucks, and until it delivered all of them. And then it provides a report here, and it kind of tallies the time that the truck was returned to the hub after making all its deliveries, the total time that was taken, the miles driven, and then it gives a total miles of all the trucks that were driven. Here is 130 miles to deliver those 40 packages. So that's great. That's how that works. We'll try this. I'll go ahead and just do this with option number 3 because it's basically the same as option number 2. I'll enter a time here, say like, let's see how things are going at 9:45 a.m. Okay, and here now it prints and now this is pulling from the hash table and the package number here, and you can actually see the way that the hash table works in this case because it's running through the modulus 0 here, 10, 20, 30, 40, all with the 1's digit ending in 0, giving the status of the package information and then the status as the final field here. This package is still at the hub. And then this next package was actually delivered by 9:45. So it updates the status from at the hub to delivered and provides a timestamp for when that delivery was accomplished. And there's one more status that should be in here somewhere because packages, once they're loaded but haven't been delivered yet, here they'll show up as en route. So that's how that works. And let me just run through this one more time. There's a little bit of an error management here, like if a user tries to enter an invalid option, say option number 6, which there is no option number 6. 7 tells you that it's invalid entry and then waits for another input. And in this case, we'll input number 4 because we're done with the walkthrough and we want to exit the program. So thank you very much for listening, and I hope you enjoyed it.